Okay, good morning, ladies and gentlemen. Okay, the date for today is January 30, 2024, and the time is around 3:10 a.m. Okay, my topic for this morning will be a continuation of my long video format topic, trigonometry, and we are now on lesson number 53. We are almost done. Maybe after this, I will give you one more topic and I will be introducing a new long video format topic. It could be power transmission maybe. So for those of you who are in the age range 45 to 54, they are the only ones watching my long video format. This is for you guys. The next time around, I will be discussing maybe power transmission. Okay, let's proceed. The subject matter for this morning will be trigonometry, and this is lesson number 53. The last time around, we are through with lesson number 52. That is the so-called introduction of the so-called inverse trigonometric function. Since we know already the concept of inverse trigonometric function, I will now be giving example problem on the so-called concept. Okay, let's proceed. Subject matter for tonight will be trigonometry, or for this morning rather, trigonometry lesson number 53, and the title of the topic is example problem on inverse trigo functions. It will be the application of the trigo, the inverse trigo concept. Okay, the problem is this one. Evaluate the value of sine of open quantity, arc cosine of 0.8 plus arc sine of 0.8, closed quantity, and the problem is asking what will be the value of this one equal to. Okay. The solution of this should be by using the so-called inverse trigo function, because there could be another solution, but it does not fall under the so-called inverse function. We will just use the second solution as a check for the validity of the resulting answer. Okay, let's proceed with the solution of this one. Solution. We will represent the first one here to be x, and the second one to be y. Because this first portion here is actually an angle, and the second portion is also an angle. So it could be angle number 1, this should be angle number 2. Because preceding these two angles here is actually the sine function. So meaning to say, if we try to take the sine of this, it is just but natural that the quantity inside will be two angles, the sum of two angles. That is angle number 1 and angle number 2. But for the main solution, we will be presenting the so-called inverse trigo function concept, the concept of inverse trigo function. Okay, so we will let arc cosine of 0.8 to be x, and arc sine of 0.8 to be y. Okay, so as a representation, I let x equal to the arc cosine of 0.8. This portion here is now an inverse function. That's why our topic for tonight will be the application problem of inverse trigo function. If x is equal to the arc cosine of 0.8, taking the cosine of both sides, the cosine of x will be cosine of x, and the cosine of the arc cosine of 0.8 will just be simply 0.8. Okay? No more cosine to the minus 1, because like what I said from the previous lesson, the cosine of the arc cosine to the minus 1 of any function angle of x should be equal to x. Okay? The cosine of the arc cosine of x will just be simply x. So we are following this concept here. So if we try to take the cosine of the right hand side, what will come out will just be simply 0.8 by using this concept. So from this value here, cosine of x, 0.8, it can be written as a fraction, right? 0.8 could be the ratio 8 over 10. So it could be the value 0.8 can be written as 8 over 10. X here as an angle. So if we try to draw a right triangle, this should be x. And if the cosine of this is 8 over 10, the adjacent side should be 8, the hypotenuse will be 10. So the resulting opposite side, considering angle x, it will be equal to 6 by using the so-called Pythagoras principle. The opposite side should be the square of 10 minus the square of 8, and that will be 100 minus 64. So this side here will become the square root of 36, and by using the positive sign, this portion here should be 6. We needed this side here to compute for the other value, because if cosine of x is 8 over 10, of course the sine of x will be 6 over 10. So that's why we must have to compute for this. So when we take the value of sine of x, it will be the ratio of this side here, opposite, over hypotenuse. So sine of x should be 6 over 10. What's the relevance of this 6 over 10 here? It is a part of the so-called solution. Later on, I will try to show it. For the second representation, we will let this portion here to be equal to y. You could make any representation, but here I represent the first one as x, the second one as y. See? Right? So if y now will be the arc sine of 0.8, if we try to take the sine of both sides, the sine of y will be sine of y, and the sine of the arc sine of 0.8 will just be simply 0.8. Okay? How come this is now 0.8? If cosine of cosine to the minus 1 of x is equal to x, similarly, sine of arc sine to the minus 1 of x will also be equal to x. Okay? Because actually this cancels. That's why it's equal to x. So for the second representation, the sine of y will be the sine of the left hand side will be sine of y, and the sine of the arc sine of 0.8 will just be simply 0.8. And what is 0.8? It's the ratio 8 over 10. Okay? So again, if we try to draw a right triangle from this value of sine y, this will be y. Sine of y is actually 8 over 10, right? This should be 8. This is 10. That the ratio of this side here over this is actually sine of y. So this should be 8. This is 10. And for the resulting adjacent side, it's the same as from the first one. It will be the square of 10 minus the square of 8. And what will come out will be the square root of 36. And the square root of 36, by using the positive sign, it will be 6 units. Then we'll try to take the value of the cosine, because later on we will be using the value of cosine of y. So cosine of y, it will be, by definition, cosine of angle y should be adjacent over hypotenuse. So this is 6 over 10. Again, we will be using this value in the final solution. Right? So if we try to go back to the original problem, the sine of the quantity, the arc cosine of 0.8 plus the arc sine of 0.8 close quantity equal to the sine, okay? From our representation, the first one is actually x, The second one is y. Okay? So by following this representation, it will now be equal to sine of the quantity x plus y. Okay? We got a problem here. We must have to expand this one. Okay? We pass by the topic, the sine of the sum of two angles. The sine of sum of two angles is actually a sine and a cosine and a cosine and a sine. Okay? The operation here is addition, right? So this will be plus. This is x, this is y, this is x, this is y. So the expansion of the quantity sine of the quantity x plus y will be sine cosine, cosine sine. First angle, second angle, first angle, second angle. If this is plus, this should be plus. So the expansion of this one, it will be the product of sine of x, cosine of y, okay, plus cosine of x, sine of y. This is now where the problem sine of x, cosine of y, and cosine of x, sine of y will come out. That's why in the preceding the solution, we brought out the value of sine of y, simple is cosine of x, right? And the so-called cosine of y. So by following this expansion, it will now be sine of x, cosine of y, plus cosine of x, sine of y. We are now given all the values of this one. Okay, so if we try to substitute the values now, what is sine of x? Sine of x is actually 6 over 10, right? 6 over 10. That's why this is the reason now why we computed this one, because in the final solution we needed this value here. We think ahead what we needed in the final solution. We needed the value sine of x. Sine of x is actually 6 over 10. Cosine of y, what's cosine of y? 6 over 10 also. Right? What is cosine of x? Cosine of x, it's what's given, right? Cosine of x is 8 over 10. This is 8 over 10. And what is sine of y? Sine of y is 8 over 10. The one given. Right? It is 8 over 10. So this is multiplied by 8 over 10 also. The operation here is multiplication. The middle operation is addition. So 6 times 6 will be 36. 10 times 10 will be 100. The middle operation is plus. 8 times 8 will be 64. 10 times 10 will be 100. We must have to combine this one. This is now a part of algebra. We are adding two fractions with the same denominator. So the resulting simplification will be the sum of the individual numerators, right? All over the common denominator. Same denominator, 100 and 100. So this will become a 100 over 100, and 100 over 100 is actually 1. So the final answer here is actually the sine of the so-called arc cosine of point A plus the arc sine of point A plus quantity equal to this value here is actually equal to 1. Okay? This is the unknown value. And to try to check the validity of our answer by not using inverse trigo function, in here, if we try to go back, we are taking the sine value of this two function here. So meaning to say, the two functions inside are actually two angles. So this should be first angle, second angle. And actually, we could compute for the angles. The first angle is actually the arc cosine of point A. So we'll just, okay, I will get my eyeglass. We'll just display point A, arc cosine, second function cosine. The first angle is 36.86 degrees. So this is 36.86 degrees. What's the second angle? Arc sine of point 8. Again, we will display point 8. Second function sine. We could compute for the angle. 53.13 degrees. So the second angle here is actually 53.13 degrees. Okay? So if we try to take the sum of this is approximately 90 degrees. Right? And the problem is just asking what is the sine of these two angles here. The sum of the two angles is 90 degrees, and the sine of 90 degrees, okay, it's a special angle. Sine of 90 degrees is 1. Okay? So this answer here is actually correct. So because if we try to take the sine of the sum of the two angles, it will become the sine of 90 degrees, and the sine of 90 degrees, okay, even though you do not use your calculator or not even drawing the right triangle, the sine of 90 degrees is actually equal to 1. So this is 1, so it is true. So our answer 1 is correct, okay, since per verification, the sine of 90 degrees is actually 1. Okay, that's it, guys. That's how we solve this problem here involving the concept of inverse Trigo function, and we check the validity of our answer by solving first the two angles, adding the two angles, then taking the sine value of the sum of the two angles, and that will be equal to the sine of 90 degrees, and this is 1. Okay, we are almost done with trigonometry. So for those of you who would like to subscribe to my channel is at youtube.com/Prof. David J. De Los Reyes. If you want to share it, please click share. Okay, the next time around, I will be discussing the last topic under the long video format discussion, trigonometry. Okay, good morning from Los Angeles.